As I was saying, you just want to stick the probe sideways like that, and then on the other side until the device actually ends up reading something. If you get a short reading, don't automatically panic. First of all, make sure that you're not testing a diode, and I see here D64 something. This is a diode, so I'm not really testing it properly. That thing underneath is a diode. Let's see it up there on the same board. Yep, that is a diode. The one next to it is also a diode, but those three are transistors. So what you want to do with those, well, those three are also exposed. Those three are not, the upper ones. So here is this open. So what you want to do is you want to just stick it on one side. You may try and watch where it is, and then stick it to the other. I am getting a reading on a meter. Let me see if I can tell that. I'm getting a reading on a meter that says 10 something. That's 1059. That's anything but short. If you switch directions, it would probably be even less, but even if it's even more, I'm sorry, but even if it's less, that's still far away from short. None of those is shorted here, and that's a good sign for you. That is likely, but not certainly, a working board, because a board can fail in many ways, not necessarily by shorting. Another note, not just the SMD diodes, and transistors. Yeah, a note, you will very rarely see shorted diodes. If you see a shorted diode, it might be because it is in parallel with a transistor that is shorted. And my experience is that diodes rarely go bad here. Some of those components are in parallel, so if one of them is shorted, all of them will show shorted. How do you find which one is shorted? Well, whenever there are several of them that work in parallel, if one gets shorted, we here always replace all three of them. For a number of reasons. It's not exactly a must, in the same fashion in which if you blow a tire, you don't have to replace all 4 tires. But there are reasons when this is actually better, time-wise, resource-wise. It's not that expensive. If you get to work on those, if you heat a lot to replace one, replacing the other two doesn't cost me a lot of time. But like with if you crash a car and you replace what's visibly broken out there may be cracked components in that car, which when you start driving again, they become under pressure again, and then they blow. It's very, very similar, and then they crack. It's very, very similar when it comes to electronic components, especially on a power failure. So it is always wise to replace as many surrounding the failure as possible. Now what I wanted to show is that not necessarily always it is the SMD components that fail. On this board we have seen that one fail too, and you can test it the usual way. You actually can't see, but this one we've replaced with a not OEM replacement. We just didn't have the original, so we read the parameters on it, we saw what we needed, and we just substituted with the best that we can get from a reliable local source, as opposed to waiting for possibly used component from Asia. So this is a brand new different style transistor. We had to put the insulation on top of it, but it works just fine. So on this particular board you want to test this. You also want to test, let me see, where was it? It actually failed on that board. This one. Small one. That one had also failed. We have only seen semiconductors fail on that board. We have not seen power resistors. We have not seen this one or that one. Doesn't mean it can't happen. It means that in a number of boards that we have seen, you don't need to go about those. So we fixed it. We measured it. We put it back in the TV. And the TV, actually the way it worked is we first those were bad. So we replaced them, tested the rest, of course, put it back in the TV. It cracked, blacked, and I think that one failed then, or maybe this one was the second. Fixed it, then this one failed. rarely it will be so multi-steps, but eventually it came up to a point where we couldn't see anymore what was wrong with the board. We stick it in our TV over there, and it worked out fine. But this TV kept on giving 7 blinks. And the reason it kept on giving 7 blinks was because not only that board was bad, but one of those too. Now, how do you find that one of the buffer boards is bad? Very similar again, you're seeking for shorts, although remember that's not necessarily the only way. You know, finding a short is where a short shouldn't be is a guarantee that something is bad. But not finding a short anywhere doesn't still mean that everything's fine. Sometimes when it fails, it may fail in a way that does not have a shortage. The easy way to find if there is a problem here is to test for resistance over those brown capacitors. There's one here, there's one here, there's one on the upper buffer board. And what you're gonna get is this. And that. And this. I'm getting 4 ohms here. And that's not right. Now, right now the two of them are in parallel, so all those are in parallel to here. If I disconnect this connector and I run the same test, oh well, let's do it that way. First, I'm still keeping it closed, and I'm measuring the same. Those are the capacitors for the sustained output voltage, by the way, for the buffer ICs that let out to the display itself. So you get the same short here on the top buffer board that you get here on the bottom. Well, power to the top buffer board comes from this connector, and if I remove that, there is no more short here, and actually registered 0 on the device. Now, if I measure here, it is still full. So it tells me that board is bad. That can be a little confusing because if you disconnect both of those and you try here, there's also nothing. This is misleading, and I won't stop to explain why. You know, if you test it that way and you discover shortage, intuitively you may conclude that yeah, this is what is causing the shortage, but there is no short anywhere here. The short is here. And usually what shorts out is one of the ICs. I believe I had a different video for when we repaired the top buffer board over there at our unit. Here I'm going to show you how to find which of the ICs is indeed bad, and also double check the findings that there is something that is shorted. We can do it on the top buffer first, and then I will show you how to do it on the bottom. On the top buffer, in the same diode mode, you want to stick the positive probe to the ground, floating ground, and you want to open those. And what you're going to do is you're going to test through the pins. Watch how I move relatively slowly. While I move it, take a look at the meter. What it's going to read is a reading of 0.60 something, and as I move, if I put the probe so that it fails between two legs, it gives me the net resistance of the two of them shorted, which is 0.65. And if I touch just one output pin, it's going to be slightly higher, 0.58, I believe. Yeah, 89. And if I slowly move around, it just gives me the same reading all over the place as I'm moving. If you move them slower, it can actually say tack, 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 tack the device itself, if it is designed like the Fluke to do that. Now if I move to the lower one, all of those ones are good, and you can actually, you should do the same on the outside, right here underneath. But the problem here is on the bottom buffer board, which first you have to remove this. I've left it open because that's where it is. Again, take take this. Alright, so taking the system output floating ground, getting the device, and going through here. You can't see it. Actually, I'm moving, and I stopped here, and it's giving me a short. It's beeping, it's giving me 7 ohms. If you look closer, let me see how close we can look at that. Hold on a second, sorry. That's zooming, not getting closer. If you trace the little tracks that come out of this connector, well, those ones come to this unit. Those ones, and it was shorted somewhere here. I don't see them well from that angle, but it's going to be either this IC or that IC. And the way you find out is you got to just look very carefully at the tracks. There were some of those first ones, so I'll have to see where they go underneath, because the tracks that are on the top start from this leg. The other ones probably go a little bit back through the board, and then they go somewhere. But once you know which pin here gives the short, you can trace it and find out which of the two ICs is bad. Sometimes when you take out the bad IC and replace it as we do, and put it out and put it in, pretty much like the cracked car components that I explained before, another one may fail. This is relatively rare. Most of the time, if one IC is bad at this point, and you replace it, it's going to be just fine with another. That is all for today. Hopefully it helped, and good luck in your repairs.